Okay, hi guys! So, my name is Siti Haratul Maisara binti Muhammad Fitri. My ID number is 2024-434-164.
And my name is Nubashira binti Mazlan. My metric number is 2024-633-882.
Okay, now, let's see our recap!
Far across the blue water, away over yonder, by the banks of the old river Rhine, where I loved her and left her, but I can't forget her. I miss my pretty Proline.
Okay, so now we'll start with practical 1, basic concept of statistics and variation. Okay, in this practical, we explore statistics and variation, learning to calculate measures like mean, variance, and standard deviation. These tools help analyze data distribution, study biological patterns, and interpret scientific data. Okay, so as you guys know, this set was stood at Putrajaya. I will be shortly for this set 1, set 2. Meanwhile, the set 3 will conduct with my partner, Bashi. So, in this practical 1, we have collected 30 leaves for set 1, set 2, and set 3. This practical itself has their own formula which is we need to follow to get the real number. So, in set 1, the leaf length average from 6 to 9 cm. So, to get the mean, we need to sum all these leaves length and divide with total leaves but minus 1. So, the second table is variance, which is the mean just now. We have to square it and divide with total leaves. The last table, we need to square root the answer of variance. Besides, the average with leaves is from 3 to 5 cm. For these leaves, we use the same leaves which is we measured the last time, length and width. So, the calculation is same like formula length. Okay, so for set 2, the average for leaf length is from 6 to 9 cm. The length difference with set 1 is about 2 cm. So the formula is still same, which to get the mean need to sum all the length and divide with total leaf. To get the variance is still same, which we need to put square, and last for standard deviation, just square root the answer. Okay, now we move on to leaf width. The average width is from 3 to 5 cm. The calculation formula is still same like length.
Next, we take the statistical analysis of leaf measurement from set 3 focusing on leaf length and width. We'll calculate the mean, variance, and standard deviation for both. For leaf length, we have 10 measurements ranging from top 7.4 cm to 8.6 cm. The mean is 7.79 cm. The variance is 0.471 cm to square root, and the standard deviation is 0.6871 cm, showing low variability in the leaf length. For leaf width, the measurement range from 2.9 cm to 5.5 cm. The mean is 3.36 cm, the variance is 0.669 cm, and the standard deviation is 0.8814 cm.
Okay, now we move on to the post-let question 1. So, the question is about discuss the differences or similarity of the mean of length between different set of leaves. Do the same for the mean of width. So, the answer is set 1 had the longest average length, which is 8.17 cm, and set 3 the shortest 7.79 cm, with a range of 0.38 cm. Minor differences may result from the sample variation, climate, or growth, but the uniformity suggests the leaves are from the same species or collected similarly. Okay, next answer, leaf width shows greater variation with set 1 3.91 cm and set 3 3.36 cm, differing by 0.55 cm. This suggests width is more influenced by factors like sunlight, water, or genetic variability. Okay, now we move on to post-let question 2. What is meant by variance? The leaves had different measurements of width and length. What is the meaning of this statement? Discuss with respect to variance what is meant by standard deviation. Okay, so Variance quantifies how data points deviate from the mean, calculated as the mean squared difference from the mean. For step 1, leaf length variance 0.5268 is higher than width variance 0.3165, indicating greater variability in length. The standard deviation, the square root of variance, measures depression in the same units as the data. Okay, so for the last postulate question, what is necessary to have different sets of measurements for the measurement of leaf width and length? Different measurement sets provide a better understanding to leaf variability, accounting for environmental, sampling, or tree-section differences. Analyzing multiple sets ensures consistent, unbiased results.
So then we go to the practical 2 of introduction. In this practical, we study the factors that influence the distribution and evidence of organism inhabited. By using quadrats, we observe and record the types and numbers of plant species in different areas. These activities help us understand how factors like soil, water and competition affect where organisms are found and how many are present. The practical also highlight the importance of both biotic and abiotic factors in shaping ecosystems. Next, we go to the practical 2 of the result. At the site 1 in Taman Botani Putrajaya, the quadrant 1 was used to study the distribution and density of 6 plant species within a 25 meter square area. The most dominant species were Drybanelabs aromatica with the high density of 0.08 individual per meter square, while all the other species such as Elacarpus nitidus, Tectona grandis, Sindora, and Chinocalax and Pericia insignis has lower densities of 0.04 individuals per meter square. The spatial arrangement of this plant shows that Drybanelabs aromatica may be better adapted to the environment of more competitive. The even distribution of other species suggests a minimal competition with possible microhabitat preference influencing their placement. This study highlights how different species coexist and interact in the ecosystem, providing valuable insights into plant community structure. Next, we go to the postulate question for practical 2. In this postulate presentation, I will discuss the main point for our practical on factors affecting organism distribution and evidence. A quadrat is a frame used to sample specific areas in ecology studies. It helps study the distribution and evidence of organisms like plants or small animals. To use quadrat effectively, we need randomly sampling to avoid best consistent quadrat size for accurate comparisons. For the largest quadrats, give a better view of the population but take more time and resources. Smaller quadrats are easy to handle but may miss rare species, making the result less accurate. Estimate the densities in complex habitats like dense forests or water is difficult due to visibility and other factors. Advanced methods are often needed. Finally, difference in plant species across quadrat are influenced by factors like microhabitats, resource disturbance, habitat change, and invasive species. These factors, along with sampling bias, explain why plant diversity varies. This practical shows the importance of proper sampling to understand species patterns.